Fields of material science have recently gained attention as Michio Kaku has affirmed that the James Webb Space Telescope, JWST, has observed 6 enormous structures that experts previously thought couldn't exist. These evaluations have the potential to open up new perspectives on how we interpret the universe. The discovery is both engaging and moderate, challenging existing speculation about the improvement and progression of galaxies. It is therefore worth watching out for these updates. The affirmation by such a recognized expert highlights the significance of these disclosures. Michio Kaku is a prominent figure in the scientific field, a physicist of American and Japanese heritage. He is seen as a master in both conventional exploratory material science and quantum mechanics. Unlike some more moderate and questionable experts, Kaku has been open to the unbelievable ramifications of the JWST mission. His eagerness to embrace new revelations and share them with the public accentuates his commitment to pushing our understanding of the universe. We are satisfied that this recognized professional has chosen to end his silence and straightforwardly share what can no longer be denied. The fervor and almost connected tone of the notable physicist are apparent in his remarks on the revelations made by the JWST, showing that this has been a feature that has blended his interest. Join us in exploring the repercussions of Michio Kaku's disclosures concerning 6 gigantic structures. Kaku is a significant researcher who has consistently been able to consider new theories throughout his life. He has shown a responsiveness to ideas that challenge the norm, recognizing that Einstein's theory of relativity and Newton's laws, while fundamental, are failing to fully capture the intricacies of the universe. Kaku understands that the revelations of the new telescope can potentially enhance the scholarly field. However, many of his peers have not embraced this view. This has caused concern and restlessness among the Big Bang supporters and rivals of quantum mechanics. However, this only incites laughter from Kaku. The JWST has uncovered the presence of 6 huge galaxies tracing back to the earliest epochs of the universe. Each of these gigantic structures contains more stars than our own Milky Way, despite having formed only 200 to 700 million years after the Big Bang. The group of astronomers who made the revelation has named these sensational systems universe breakers, as their confirmation would change our entire understanding of the universe. The ramifications of these exposures are enormous, suggesting that the universe's initial years were considerably more powerful and complex than previously thought. The speculation of how things came to be tells us that the universe was a tumultuous mass after the initial event. The principal strong objects were expected to take an enormous number of years to form, and it took endless additional years for the objects to reach adequate density and produce light. The type of intricate designs, for example galaxies, was believed to happen much later. Some of the newly discovered galaxies exceed the Milky Way in size, and their tremendous brilliance suggests that they were likely forming many new stars each year, while our galaxy forms stars only sporadically. It remains unclear precisely when the first galaxies formed. Scientists have not been able to determine this up to this point. The only thing that is clear is that initially, there may have been only single stars or groups of stars, which ultimately coalesced to form progressively larger structures until dwarf galaxies were fostered. These small celestial structures experienced various designs and continuously advanced, contradicting past theories that large galaxies couldn't have existed at that time. This raises the question of whether the universe is much older than previously recognized or whether complex galaxies formed altogether sooner. This present situation is challenging to acknowledge for standard science, which still struggles with this model. Several aspects of material science unequivocally refuse to acknowledge this disclosure and question potential mistakes in the age estimates. Kaku is aware of this and had this to say: "There are different models of old and deceptive hypotheses that determinately continue due to the influence of certain experts. Many of these hypotheses were perhaps disproven when critical investigations uncovered their defects. Thus, the major word in any science, particularly in physical science, rests within the experimentalists who keep scientists ready and mindful. Indeed, on Earth, we have barely any knowledge into the bona fide starting points of the universe." This explanation from Kaku highlights the significance of consistent trial and error as well as validation in the scientific process. The speculation of how things came to be was laid out in 1927 based on observations of the development of the universe. This data led to the conclusion that the universe began from a solitary point and has been expanding from that point onward. At the time, it was hard for individuals and researchers to envision a universe with a start and an end. The idea of a universe that had always existed and was boundless was generally beyond individuals' imagination. Without a doubt, even today researchers still face challenges in figuring it out. However, it is essential to consider these possible outcomes, even if these new disclosures do not fit with what scientists have been positing for quite a while regarding the Big Bang Theory. Regardless, science has consistently shown that reassessment and receptiveness to novel thoughts are a major part of the scientific process, similar to the certification of specific theories and observations. When Einstein was a child, it was believed that the stars and planets were solidly fixed in the universe, and these specific formations consumed a defined space. However, we now realize that everything in the universe is moving. Planets circle, stars move within their galaxies at various kilometers per second, and entire galaxies move quickly through the universe, the fate of which we can't yet even anticipate. This new comprehension of the universe challenges long-held beliefs and highlights the need for ceaseless inquiry and change in scientific thought. Today, researchers are challenged to acknowledge uncomfortable pieces of understanding and to grasp that theories are not absolute insights until they are fully tested or confirmed by exact observation. The idea of the Big Bang emerged from the acknowledgement that galaxies are getting away from each other, and this distance is relative to their separation from Earth. This perception, known as Hubble's law, proposed that the universe was expanding for quite some time. Components such as the cosmic microwave background radiation and the redshift of light from far-off galaxies, alongside other cosmological patterns, appear to support this theory. However, recalling that is fundamental. Previously, individuals who believed the Earth was flat and that the Sun rotated around us also had observational evidence for their questions until events or mechanical advancements came along that provided a clearer picture. Right now, we are seeing a comparable circumstance. Researchers expected the new JWST to confirm the doubts connected with the Big Bang. However, they have come across these 6 galaxies that appeared impossible. This shows that science is continuously advancing and that specialists should be present to new revelations and rethink existing theories in light of the available evidence. The alarming disclosures challenge current understanding and insight, prompting a reassessment of well-established cosmological theory. Scientists use redshift as a tool to determine certain amounts in the investigation of the universe. Redshift, also called the Doppler effect, refers to the adjustment of the variety of light as light sources and observers move relative to each other. To understand this, you can imagine standing still and seeing a vehicle coming toward you. As the vehicle moves toward you, you hear the motor getting louder. However, when the vehicle passes you or moves away, the motor sound changes. This is because the sound fluctuates as the vehicle moves. The same is true for light. When a light source, for example, a far-off star, moves toward us, the light we see shifts toward bluer tones. Alternately, when the light source escapes from us, the light moves toward redder tones. This peculiarity is called redshift. Physicists have converted redshift values into speeds and distances for measurement in the investigation of the universe. However, it is important to note that even a small error in these estimations can have huge consequences. The estimation procedures recently utilized are now under review. The latest revelations connected with our universe require consideration of whether they are genuinely based on redshift errors or whether some researchers are simply denying the realities. This is an inquiry that requires careful examination and cautious review of the information and techniques used in the research. The current examination and reassessment of estimation procedures highlight the developing nature of scientific inquiry. Thank you for watching the video. As always, we remind you that you can post your inquiries in the comments box. If you enjoyed the video, make sure to raise a ruckus around the town, like the button, share it so it reaches more individuals, and subscribe to the feed so you don't miss more content like this. Thank you for watching and see you in the next one. This source of inspiration enables watchers to engage with the content, empowering a community of inquisitive minds eager to explore and grasp the latest scientific discussions. The assessment of our universe, with its vast breadths and complex celestial bodies, continues to interest and challenge researchers across the globe. From early speculations about the universe to the most recent disclosures made possible by cutting-edge technology, Each revelation reshapes how we comprehend the universe and stretches the limits of human knowledge. One of the most critical and enduring inquiries in cosmology revolves around the beginning and advancement of galaxies. Galaxies are like communities of stars, gas, dust, and dark matter bound together by gravity. Figuring out how galaxies form and develop is indispensable not just for disentangling the mysteries of our universe, but also for certifying or testing existing theories, such as the hypothesis of the universe's starting point. The hypothesis of the Big Bang, proposed almost a century ago, suggests that the universe began from a solitary, infinitely dense point and has been expanding from that point onward. This thought emerged from observations of the universe's expansion and the cosmic microwave background radiation, which are viewed as the leftovers of the early universe's extreme intensity and light. However, ongoing disclosures, especially those made by the JWST, have tested several key suppositions fundamental to the Big Bang hypothesis. The JWST, with its extraordinary awareness and resolution, has identified galaxies that appear significantly larger and more developed than anticipated for their age. One such disclosure involves 6 enormous galaxies tracing all the way back to when the universe was merely 200 to 700 million years old, a mere flicker in its 13.8 billion-year history. These cosmic systems, named universe breakers by the research team, challenge traditional understanding since they are already so large and bright at such an early cosmic stage. The revelation of these cosmic systems raises intriguing questions about the rapid advancement of the early universe and challenges existing models of galaxy development. According to prevailing theories, galaxies form steadily over billions of years through the merging of smaller structures and the accumulation of gas and stars. The presence of these large systems so early in cosmic history suggests a more complicated and potentially quicker cycle of galaxy development than previously suspected. Additionally, the revelation highlights the significant role of mechanical progressions in reshaping our comprehension of the universe. The JWST's capacity to peer further into space and catch faint light from distant galaxies has permitted astronomers to unveil previously undetectable aspects of the universe's early development. These perceptions provide valuable insights into the circumstances and cycles that governed galaxy formation during the universe's earliest stages. The ramifications of these revelations extend beyond the realm of astrophysics. They challenge researchers to return to and refine existing cosmological models to better represent the observed variety and intricacy of galaxies across cosmic time. They also highlight the dynamic and evolving nature of scientific knowledge, where new discoveries can prompt paradigm shifts and open new avenues for exploration. As researchers continue to examine and interpret the data from the JWST and other observatories, the investigation of galaxy development remains a dynamic and developing field of research. Each new revelation brings us closer to unraveling the mysteries of our cosmic beginnings and grasping the essential cycles that have shaped the universe as we know it today. In conclusion, while the discovery of these 6 tremendous cosmic systems challenges our current understanding of galaxy formation and the early universe, it also represents a critical milestone in our quest to unlock the universe's secrets. By pushing the limits of scientific knowledge, such revelations pave the way for future breakthroughs and expand our curiosity about the vast and complex tapestry of the universe. The implications of these groundbreaking discoveries also raise fundamental questions about the nature of dark matter and dark energy. As astronomers uncover more about the structures of the early universe, they must consider how these elusive components influence galaxy formation. Dark matter, which does not emit or absorb light, is thought to comprise a significant portion of the universe's mass. Understanding its role in the development of these massive galaxies could lead to a reevaluation of current models. Furthermore, the findings could impact our understanding of the cosmic web, the vast network of galaxies and dark matter that forms the universe's large-scale structure. As these newly identified galaxies interact with their surroundings, they may shed light on how matter coalesces and evolves over cosmic time. Moreover, these revelations may also inspire new observational techniques and technologies aimed at probing deeper into the universe's infancy. Future telescopes could further refine our understanding of galaxy evolution, offering insights into the conditions that fostered such rapid growth.